Chapter 8, Section 3 Examples. Example 1. Calculate the mean and median for the following PDF. Notice here that for this particular PDF, we can find the equation of this line using the points 0, 0.1, where it intersects the y-axis, and the point 20, 0, where it intersects the x-axis. Doing change in y over change in x for the slope and using the intercept, we get that our probability density function has an equation of negative 0.005x plus 0.1. Now that we have the equation, we can find the mean and the median for this PDF. Remember, for the median, the general formula is the integral from negative infinity to t of our PDF equals 0.5. Here, our PDF is defined from 0 to 20, so instead of negative infinity, we'll use our starting point of 0. So we're going from 0 to t, negative 0.005x plus 0.1, and we want to know when does that equal 0.5. When we find the general antiderivative, we are going to get negative 0.0025x squared plus 0.1x from 0 to t. Plugging in the capital T, we get negative 0.0025 t squared plus 0.1 t, and then we'll have minus 0, so we don't need to write that, and we want to know when that equals 0.5. So again, when we have a squared term, we want to put everything on one side of the equation. So bringing this term over to the right and the 0.1 t term over to the right, we get 0.0025 t squared minus 0.1 t plus 0.5 equals 0. Using the quadratic equation, we can now find the values of t, which will solve this equation, and those two values are t equals 5.86 and 34.14. Remember that we want the t that's between 0 and 20, so here that would be 5.86. So the median of this PDF is 5.86. For the mean, again, our general formula is negative infinity to infinity x times probability density function. So here, we're defined from 0 to 20, so those are our bounds. So we do x times our PDF, which was negative 0.005x plus 0.1. We can distribute that x through, so we have the integral from 0 to 20 of negative 0.005x squared plus 0.1x dx. When we integrate, we get a general antiderivative of negative 0.00167x cubed plus 0.05x squared from 0 to 20. Plugging in our bounds and subtracting, we get 6.64. So the mean here is 6.64. Example 2. Let's look at a normal distribution problem. The average daily food consumption of a sumo wrestler can be modeled by a normal distribution with a mean of 5 pounds and a standard deviation of 2 pounds. Compute the fraction of wrestlers who eat between 5 and 7 pounds a day. So again, our general PDF for a normal distribution always looks the same. It always looks like this. 1 divided by sigma square root of 2 pi times e raised to the power of negative x minus mu squared, all divided by 2 sigma squared. So again, we're going to be plugging in a 2 for sigma, since that's our standard deviation, and then we're going to be plugging in a 5 for our mean. So the 5 goes up here, and a 2 goes in here, and here from our sigma. Now we're going to be calculating the area from 5 to 7, because we want to know how many eat between 5 and 7 pounds a day. So we very, very carefully plug this into our calculator using lots of parentheses, and it should give you 0.3413. So that means approximately 34% of sumo wrestlers will eat between 5 and 7 pounds of food a day.